All right, everybody. So welcome. As I said, thank you for joining us today on the very last day of term. I'm sure that everybody is ready for a very well-deserved holiday, and we're almost a few hours away from that. So welcome today. My name is Matthew Heskett. I'm the Manager of Skills and Education here at the Queensland Minerals and Energy Academy. And we've got for us today a very important guest who's going to speak to us about his pathway into his area of expertise, but also talk around about some of the chemistry that's involved, in particular in the coal industry. So we're very pleased and very happy to have today Scott Southwood, who is the General Manager of Marketing at Batchfire Callide. I won't steal too much of Scott's thunder because I know that he's got some slides and some things that he wants to share with you today. If you do have any questions, please feel free to type those in the chat box. What we'll do is at the end of Scott's session, there is a time for student questions. I've got a couple of questions that I'd like to ask Scott as well, and then we'll go through there and answer any questions that you do have. We also have on the line a couple more QMEA staff. So Jessica Heineman will be monitoring that chat box for questions, but we've also got our other STEM enrichment officers, Jen Hoyle and Sylvia Clark, have also joined us for today. So without further ado, I will hand over to Scott. I'll just bring up his slides for him. I'll hand over to Scott to tell us about his pathway, about what he did to get to where he is, and then what Batchfire does, and some of the chemistry involved, in particular within the coal industry. So thank you, Scott.
Okay, thanks, Matthew. Good morning, Redeemer kids, Biloela. Understand we've got some Blackwater High School kids on as well, so thanks for having me. Last day of term, I guess. I'll try and keep it as short as possible for you guys. In terms of, let me just start talking about chemical engineering, because that was my pathway. I'm basically involved these days in coal trading, sales and marketing. So, I guess if you're from Biloela or Blackwater, you'll understand what coal is. I'm involved in the business at the end where, we sell to our customers. I actually grew up in mining towns. I grew up in Dysart and Middlemount, so I'm no stranger to Biloela and Blackwater. I remember playing footy against Blackwater when I was a little kid. I guess my pathway was, I studied maths and science at school. Year 11 and 12, I did maths, science subjects, which was pretty dry, but I didn't know what to study for myself in those days. I didn't have a career plan, so I studied those subjects mainly to keep my options open. I ended up doing a science and chemical engineering degree at University of Queensland in Brisbane. My intention in those days was to become a biochemical engineer, but there were no jobs in Australia in that field when I graduated. So there's one tip for you guys, don't listen to universities if you go to university when they tell you to do certain subjects, because you can get international work, straight away as a graduate. It's good if you've got rich parents, but it's pretty difficult otherwise. So I went into the coal industry when I graduated as a chemical engineer. As a chemical engineer in the coal industry, basically working in coal wash plants, which is a separation process, separating the rocks and the dirt from the coal. It involves some surface chemistry for the very fine material. Otherwise, it's a density separation process basically, and it's very simple. Initially, when I graduated, I worked in New South Wales, in Wollongong and in Newcastle, and then after about, I guess it was about 7 years working in mines, I moved into the marketing side of things because I found it interesting to understand how our products were used by our customers, primarily overseas, and I enjoy travel and understanding different cultures. And marketing coal has taken me around the world. I've basically traveled to almost every country in Asia, some of them more times than I can remember. Europe, and I've worked in places like Mongolia and Russia and some places that are so remote. You'd think that Blackwater and Biloela was like Sydney compared to some of the places that I've worked. And if you have a chance, have a look on Google Earth for a place called Baranovsky or Chukotka in far eastern Russia. And I still work for a company that mines coal up there, in the tundra. In 2016, the trading company that I was involved with purchased the Callide mine from Anglo American, who obviously had it up for sale at that time. And that's what I do at the moment. Is I basically sell the coal that's produced from Callide mine to our domestic customers, which is our biggest customers are the stations next door to the mine, Callide power stations, but also to various customers overseas, mostly in Asia, Korea, Japan, Taiwan, China, India, Southeast Asia, I guess. So I'm just going to talk to you guys about chemical engineering and a little bit about science and chemistry and how it's sort of important in mining. Chemical engineering is a pretty diverse field of engineering. It's probably harder to define it than, say, mining engineering. Even though I studied it, I had to look it up on Wikipedia to come up with some sort of summary definition. So I found two definitions there, which are up on the screen. You're basically involved in processing of things, and that could be chemical processes, could be physical processes such as separating, dirt from coal, could be biological processes, many different types of things. The classic probably is for chemical engineers that, if you see them in cartoons or movies, they're working on distillation columns, in oil or gas. That's probably the main field. And there'd be a lot of chemical engineers working out on Curtis Island off Gladstone in those gas plants at the moment. So anything where something is processed or produced, you'll find chemical engineers. Some local examples. I guess I've sort of focused more around Biloela because that's where we are. Local examples would be the ammonium nitrate plant out there, where the explosives are made. The Dawson mine washing plant would have one or two chemical engineers working there. And the Callide power stations would also have, process engineers. Why is it important in energy? Again, there's a photo here of distillation columns, in an oil or petroleum plant. That's the classic kind of chemical engineering, I guess, where you're extracting, fractionating, or distilling oil into the various different, fuel products that come from there. Processing of gas, process engineering is important in power stations and steel mills, coal industry, anywhere, I guess, where there's production or utilization of energy, commodities or energy products, you'll find chemical engineers. In the coal industry, specifically, as I mentioned, there's three examples I'll talk about. First one being the Orica ammonium nitrate plant, AN plant, near Biloela. AN is used to make ANFO, and ANFO simply stands for ammonium nitrate fuel oil. We drill holes down into the earth. We send this powder. We put this powder down in the bottom of the holes, and we put a detonator in it. And then we blow the crap out of it, and you can see in the photo there that's one example of a mining explosion. We do that to soften the ground so that we can dig it up and move the dirt away to get to the coal down below. I guess maybe you've seen a coal mine in your time. The production of ammonia is a very simple reaction. You mix ammonia with nitric acid and you make ammonium nitrate, NH4NO3. The explosion reaction's interesting. If you just have ammonium nitrate by itself and you basically oxidize it very quickly in an explosion, you make NO2 and water, basically. So nitric oxide and water. It's an exothermic reaction, which I guess you guys will be learning about in your chemistry classes. So it releases energy and in the form of heat mostly, but also in this reaction, you know, kinetic energy, pressure, and 36 kilojoules per mole of ammonium nitrate. But you can really increase the energy of the explosion, the reaction, which is the explosion. In chemical terms, you say you make it more exothermic by adding some oxidizable fuel, and the most simple and readily available fuel for this is the fuel oil part of the ANFO. Fuel oil just being diesel. It sounds more technical than it is. You mix a bit of diesel in with the ammonium nitrate, and that changes the energy of the reaction, and you produce 280 kilojoules per mole. So it's a lot more, nearly 10, probably 8 times more power in the explosion just by mixing a bit of diesel with it. And the reaction is shown there on the screen. I guess if you're learning in chemistry about tools that help create help reactions take place, you'll be learning about catalysts and the use of temperature. In this case, the reaction requires a high temperature, 170 degrees Celsius, which is basically created by the use of a detonator. And that's actually really useful in terms of the explosion, because it allows you to control the explosion. When you mix this stuff and put it down in the ground, it's not going to just go off by itself. You can use a detonator to create the explosion, which allows you to control it. So that's a bit of an example of how chemistry is used in mining, I guess. Another chemical reaction that's of interest to us, obviously, is the combustion of the coal. Coal's used in 2 ways in industry generally, mostly I should say, not totally, but power stations, burn it as a fuel, or you put it into coke plants to make coke for use in the steel industry, which is mostly where the coal from Blackwater will go. The coal from our mine near Biloela goes in primarily into the power stations next door. The chemical reactions that occur there, where this coal is crushed, grinded really finely, pulverized to 75 microns, and then it's simply burnt in the boilers in the power station. And there's a number of chemical reactions that take place when it's burned in the boilers. The primary one is the first one shown there, where it's just coal is primarily carbon mixed with, burned in the presence of oxygen, and produces CO2 and water. That's the main reaction. And you can see it releases a lot of heat there, which is measured in the energy in terms of kilojoules per kilogram. Coal doesn't just contain carbon, it contains sulfur, hydrogen, and sometimes some other chemicals as well. So there's a number of different reactions that take place, but primarily what you're producing coming out of those big tall stacks you can see there would be carbon dioxide and water. The interesting thing, I guess, one thing that you'll be learning in your subjects will be, I guess that's maybe important, is surface, the effects of surface area on reactions. And in this case, we pulverize the coal really fine in order to create a higher surface area, which ensures that the coal is completely burnt. So you get complete combustion. You don't have bits of leftover coal in the bottom of the boilers. The only thing that comes out from the boilers is the off gases and the non-combustible material, which just comes out as what they call ash. there's a bunch of other unit processes that chemical engineers will be involved with in a power plant, such as scrubbing, which is primarily desulfurization process. ESPs, which stands for electrostatic precipitators, which are basically a whole series of plates that the gas, the smoke, I guess, goes through. They have positive charge and they collect dust to stop smoke going out the smokestack. So you should not see smoke going out of those stacks unless the ESPs are not working properly. And there may be other things like low NOx burners and other technology in power plants where sort of process engineering will be important. Last example will just be simply, coal processing plants, and there's one of these obviously at Blackwater Mine. We don't have one at Callide. These are used to remove what we call in mining, we call it dilution material. So it's basically it's just rocks and dirt that come out with the coal that shouldn't be in there. And there's two kinds of technology that are used to separate the rocks and dirt from coal, typically in coal processing plants. There's gravity separation, which does most of the work, and then there's a sort of a surface chemistry technique called flotation. Flotation is probably used more in minerals plants like nickel and things like that, but it's also used in coal for the very fine fraction. And I've got a schematic here of what they call a dense medium cyclone. So what happens in a cyclone, and what happens in a dense medium separation plant, is that you mix the raw coal, which is the coal plus the dirt and rocks, in a solution, and the solution is a solution of water and magnetite, which can be density controlled. So if you have a dense media solution running at a specific gravity of say 1.4, then if you've got coal with a specific gravity of 1.3 or 1.35, it will float to the top. And if you've got rocks with a specific gravity of say 2, that's heavier than 1.4, so that will sink, and that's how you separate. You enhance that separation by pumping the raw coal and the media into a cyclone. It enters on tangentially to the cyclone, spins around and creates a vortex. So the vortex assists with the flotation, if you like, of the less dense material which goes into the vortex and comes out the top, whereas the rocks will hit the sides and they'll go out the bottom. It's a super simple process. It doesn't involve any moving parts, and it's highly efficient way of separating rocks and coal. That probably a dense medium cyclone would work in most coal plants in Australia, and it's probably responsible for doing probably 75% of the work of, in terms of separation work of the whole industry. So that's another example of where chemical engineering, I guess, comes into effect. And just so you guys understand, I guess, specific gravity, or SG, it's just another way of talking about the density of a material by referencing it to water. So water has a density of 1,000. It's a kilogram per liter basically, or 1,000 kilograms per ton. So they reference that as a specific gravity of 1, and then you just reference other materials against that. It's basically just the amount of density compared to water, basically. That's just a short way of people use to describe density. So I guess the conclusion of my talk is that chemistry and knowledge of chemistry is important, even in sort of heavy industries like mining, where you probably don't think about it very much. The examples would be materials science. Chemistry is used to make hardened material for drilling or digging. It's important in the use of fuels and lubricants and the production of lubricants like specialized oils. When they use some highly specialized oils in open cut mining, you know, in the trucks and the diggers, but also underground. You know, in the production and use of inert gases that they pump underground to try and stop, you know, to try and make it safe, stop explosions, etc. Separation processes. It's also important in understanding the value and use of the products from mining, which, you know, is important when you're marketing and selling those products overseas. And in coal, you know, the value in use is either as a reductant at making steel, or as a fuel in combustion processes, such as power stations or paper mills where they use boilers, or in the production of cement, for example. So understanding the science of how the product's used allows people to optimize and improve the process. And, you know, those who understand it can move beyond simply working in industrial operations. So you can go into design and development, you can go into building projects, you can go into marketing, other areas of the business, which gives you more, I guess, options in terms of your career, if you understand. And that's it.
So thank you so much, Scott. Thank you so much for sharing all of that information. I'm just going to pop up a new slide. So for those of you who have joined us throughout Scott's talk, if you wouldn't mind, just in the chat box, if you could indicate which school you're from, and if you are a class that's joining, if you could please let us know how many students are in that class, just so that we're able to then track our attendance numbers, just for the number of people who are able to join us in today's session. Also at this time, if you do have any questions for Scott, whether it's about his career pathway, around what Batchfire does, around some of the science and chemistry of the coal industry and separating materials, and you know, even if it's on things like explosions and all of that sort of stuff, now's the time if you want to type those questions in the chat box on our system, and Jess will monitor that one while we start. I do just have a couple of questions that I'll ask just as we wait for those student questions to come through. So what I would like to ask to start with, Scott, is it's based around, I guess, more, this is just from my interest. Is there an opportunity for you to share with us how you go about finding customers in the coal marketing space? Is it a case where you know people who've got power stations and you actively approach them, or do people tend to come to you a little bit to try and to see if your product is suitable for them?
Matthew, it's a bit of both. So what in this space, what we try and do is we try and have a network of people that we know or who work for us in various countries who are always looking for opportunities, you know, to either develop a contract or maybe just sell one or two cargoes. So we'll have we actually have offices all around Asia. You know, we have people in Korea. We've got a couple of guys in Korea. We've got 3 people who are spread out across different areas of China. You know, for example, we've got a guy in Japan. So you have what we call sales agents in all the different countries, and they'll build up their network of contacts amongst the buyers, so that if someone is looking for, you know, a cargo or they have a tender for a long-term supply, that we're there, you know, so we're there. We can respond to a tender, which might be for 3 years or 5 years of supply to a certain customer, or it might just be, you know, one customer looking for one cargo for their cement plant or whatever. And you also get, you know, usually we have, you know, customers are doing the same thing. So they developing their network, you know, amongst the various suppliers in Australia or Indonesia or wherever, so that they can come to us if they looking for some trade as well. So it's a bit of both, really.
Yeah, no, that's great. I've just got one more question before we go to some of these student questions that are coming through. So please do continue to send those through. Um, in terms of your transition from going from a chemical engineer and working more in that technical space to going into a coal trading and coal marketing role, what sort of different skill sets were required that you may not have had, or that you may have needed to sort of tap into to then make that transition between the more technical role compared to then that coal trading and coal marketing role? In particular, things like soft skills as well.
Yeah, I mean, for me, my skill set was very, very much like hard skills. Like, I came from a highly technical background. So the soft skills were developed on the job. I worked for a big organization when I moved into marketing. And the soft skills, like, just sort of understanding different cultures. I did a course on understanding Japanese business etiquette and the way they talk and the way they sort of think. When I was in Sydney, it's just something that I picked up along the way. Mostly, there's not a lot of, I guess, there's not a lot of sort of courses you can do for those kind of soft skills. Understanding different cultures is important, but you learn that on the job. I think, I wish I had have studied languages at school. I wish I'd had the chance to study, maybe to study Japanese or Chinese language. And maybe I wish I'd studied some more commercial or financial subjects. I didn't, because, I came from Dysart and Middlemount, and we didn't have that much on offer in those days. But, you sort of pick up. I just had to pick up the soft skills as I went along.
Yeah, no, that's great. That's good to know as well. That obviously, the pathway that you take in school and then what you decide to go into uni is certainly not necessarily what you'll end up doing for the rest of your life.
I think that's important to note for the kids, because that's 100% true, especially in my field. There's the people that do coal marketing, and there's a lot of us around, come from all different areas. I happen to be from a technical background, but there'll be people who are lawyers that move into it, or accountants that move into that side of the field. You might be working in the commercial part of an organisation and then move into the marketing side. You don't necessarily have to follow my pathway to get into marketing.
No,
you do if you want to be a chemical engineer in a distillation plant. But what I do, I didn't have to follow my pathway to get where I am.
Yeah, absolutely. So we do have a couple of questions, so please do continue to send those through, students. We've got one which I'm not sure if you'll be able to answer, but I'll ask anyway. But it might be something that we have a conversation off conversation about. So Redeemer Lutheran College has asked if there's any possibility, and I presume any possibility in the future of having a tour of the site. Now, I'm also looking at the future being probably in a post-COVID world, but also is that the sort of thing that at Batch Fire Callide that you do have visitors that come on for site tours?
Well, I think not normally. We have visitors who are normally customers, who come. We have visitors who might be suppliers who come. I think it would depend on the size of the group. It's definitely something that can be done. I'll look into it from my side. Really, the only issue from Batch Fire's perspective on this would be the safety issue. We have to make sure that we can. Obviously, we have to keep separation. As you said, it's a post-COVID world. It's a possibility, and it might be. Yeah. I think it. I'll look into that. I think it's possible we can do.
Yeah, that would be great. Thanks, Scott. And we'll continue the conversations with Redeemer Lutheran College as well around that, to see what may be possible for their students. We do have another question from the Year 10 class at Redeemer. They've asked, can you tell us what clean coal is?
I think there's kind of two contexts to clean coal at the moment. In the context that I think about it and used probably in my presentation is coal that's separated and pure, from the dilution material from the dirt and rocks, and it's just pure coal. It's a pure coal product. The other sort of, it gets used differently in these days. People talk about clean coal technology, and that's got to do with, I guess that's got to do with carbon emissions and what they call, carbon capture and storage. So when people often, you might see in the media people talking about the clean coal usage or clean coal technology, what they're talking about is greenhouse gases and how you can use coal in the context of controlling greenhouse gases. And the only way to do that is to capture the carbon dioxide that comes from coal-fired power plants. And so they talk about there is some technology available where that carbon dioxide can be pumped into storage underground. But I guess there are plants in America where that's done, but there's nothing in Australia where that's done at the moment.
Okay, so rather than necessarily being a different product that you're extracting from the ground or a different process in the combustion process, it's more just what are we going to do with those byproducts at the end, and looking more probably at a mechanical process than a chemical process.
Yeah, that's
to be able to do that. Yeah. No, excellent. This question is from Blackwater State High School Year 10s. So they would like to know, and it may be, you may be able to answer a little bit more broadly than just batch fire, I'm not sure, but where overseas does the coal from Central Queensland go?
Well, it goes to a lot of places. So you're talking about coal from, the whole Bowen Basin, Central Queensland, Moranbah down to Blackwater or Mowra. It goes everywhere. That coking coal is a high value product. It goes to various countries in Europe. It might get sold in diverse places like Ukraine or Spain or Italy or the UK, France, Germany, all sorts of different places in Europe. It goes to Brazil in South America. It goes to Mexico, Argentina. But primarily, it goes to India, Pakistan, primarily Asia, of course. Japan has been a big destination for our coking coal from Central Queensland for a long, long time. These days, China is the biggest market. Of course, China's the biggest market for everything. It's the biggest market for coal as well. So, yeah, there wouldn't be too many industrialized nations that don't use our coal actually.
Oh, excellent. So thanks very much to those students who have sent those questions through. If you do have any more, we still do have a little bit more time. If you do have a couple more questions left for Scott, I've got another question for you, and I guess this is a two-part answer. Single part question, but two-part answer. What is the favourite part of your job? So what I'd like you to do is reflect back on your time as a chemical engineer. What was your favourite part of the job when you're working in that more technical space, but then also now working as a coal marketer and in coal trading? What's your favourite part of the job now?
I think, okay, so looking at from a technical perspective, my favourite part of the job was when I ran a plant down in the Hunter Valley, and we made some changes to that plant. So we retrofitted some technology into that plant, some additional separation processes, and we improved the plant, we improved the yield, and we made money as a result of doing that. And that was a lot of fun, sort of having your own plant to play with, and to make changes to getting involved in some of the design, and being a bit of an expert in that side of things. That felt good, if you know what I mean, to be able to sort of to spend money to build something that then made more money. That was fun, and that's sort of just, I guess, that was understanding the process engineering side of things and looking at an existing plan and working out how we could do something better by adding a different module of separation, if you like. But I've really enjoyed marketing the most because, I think for me, I enjoy travel. I enjoy different cultures. And I enjoy making friends in various different countries around the world, and having that sort of something extra, and you do get a buzz, even now after being in the business, almost probably 30 years, you get a buzz out of actually still, making a sale or getting some business or winning a tender. It can be exciting sometimes.
I imagine that it certainly would be. We've had another question from the Year 10s at Redeemer Lutheran College. Is it very competitive or hard to get into uni to study chemical engineering?
Look, you can get into engineering. You don't necessarily. Well, let me say this: when I did it, which is going back a while, I did it in the late 80s, and in those days, I can only talk about that in those days because I don't know these days. In those days, it wasn't that hard to get into engineering, and everybody had to do, in first year engineering, you do a bit of all different engineering. You do a bit of electrical, you do a bit of mining, you do a bit of chemical, you do all sorts, and then you choose which path you take. I don't know if it's still that way. I'm assuming it's still that way. It's a 4-year course. The first year you do a bit of everything, and then you choose which area you want to go in. And it's not, you don't have to, it's not like being a doctor or a vet or something like that where you have to get the top marks. It's probably about medium, I guess, to get into engineering. It's all different. In my days, it was TE scores. There's ATAR, there's different things now. I don't really understand the different, measures these days. But I wouldn't say it's, super hard to get into engineering.
Yeah, and I can also say that the bulk of the universities that we at QMEA deal with still have that common first year approach. So you just sign up to your Bachelor of Engineering course, where exactly as you said, you do a bit of your maths, a bit of mechanical, a bit of civil, a bit of electrical, get a bit of a taster to build up those generic skills, and then you select your major from that particular point there. In terms of the ATAR, obviously ATAR is just coming in now for this year's Year 12, so they'll be the first cohort to receive an ATAR rather than an OP score. So my advice is just to keep an eye out for the students in particular, just to keep an eye out after this year's intake to see what the ATAR score is to get into those particular courses, knowing that score is actually the lowest offer that was made in the course, not how difficult it is to actually complete the subjects. So just bear that in mind as well. It's all about supply and demand.
Yeah, and I would say if you want to go chemical engineering, you have to be a bit of a masochist. It's quite a intensive course. It's a lot of work. It's probably one of the hardest workloads I would say at university.
Yeah. So I've got another question here from the Year 10s at Redeemer Year 10. I think we've got time probably for one more question after this. So the next school to get a question in, I'm sure that we'll be able to answer that one too. How much explosive tends to get used at one time in a blast? So, for example, using the picture that you used as an example. So how much ANFO would be used in a blast like that?
I wish I knew. I can't answer it. I would only be guessing. A blast like that shown in the photo would probably have. So that's a number of drill holes will go down into that blast. That might be a blast of maybe, let's say, 40 drill holes, I guess, something like that. So they'll drill a pattern of drill holes, and they will put the powder down, and you might be talking about 20 kilos or something like that in each hole. But I'm only guessing. I'd say a bucket load or something. That's not my side of the business, so I'm not sure.
No, that's fine. I mean, my background is I used to work as an industrial chemist before I went into industry, and my industry was the paint and protective coatings industry. So it was very much bucket chemistry around, rounding up to the closest 20 kilo bag was what we used to make all our formulations on, just to make it easier to produce, because once you create 20,000 litres of something, it's very easy to then get it back into spec rather than, having to weigh out 14.67 kilos of a particular pigment or whatever like that. So completely understand that it's not your area of expertise.
I mean, I put up that slide with moles and energy releasing in exothermic reactions, but in reality, they bring in the ammonium nitrate truck, they mix it with the diesel on site, when they charge the holes, and then they put it down in the hole, and it's not a highly technical operation in terms of charging the holes. There is a fair bit of technology involved in the detonation and the blast and the timing of each blast and all that sort of thing. And these days, there's a lot of digital technology that gets used in blasting to control the blast very carefully to make sure that you don't fracture the coal seam. You stay off the coal seam when you have that explosion, so you don't mess it up. You don't blast a lot of rock into the coal. But yeah, it's not a highly technical reaction, that's for sure.
No, that's great. We've got one last question that's come in from Blackwater. So we often see chemical trucks on the road around here in Blackwater. Where does this raw or base chemical come from? And again, presuming that we're talking about, in terms of the explosives trucks.
Yeah, well, the explosives, I mean, it depends where you buy it. So some mines, like BHP, they'll go out to tender and they'll buy their explosives from whoever gives them, I guess, reliable supply and cheap source. So that could be coming from China, for example. Most likely it's coming from the Orica plant near Biloela, to be honest. That's probably produces most of the ammonium nitrate that gets used around central Queensland. It could come from Newcastle. There's a plant in Newcastle as well. Some of those chemical trucks that you see in that area, though, could be going as far as Mount Isa. You could have cyanide, or there are cyanide trucks, travelling around Biloela, so stay away from those kiddies, Yeah, no, that's going up the back way up to Mount Isa.
No, that's excellent.
And those mines up around there.
Brilliant, excellent. Well, thank you so much, Scott. Thank you so much for your time today and the expertise that you're able to provide in answering these questions. I'm sure that the students have got certainly a lot out of it. In terms of other resources, so after today's webinar, if teachers are interested, we do have our awesome resources website, oresomeresources.com. That's a place that Queensland Minerals and Energy Academy and the Queensland Resources Council, we work towards maintaining that website and putting up new resources. So we also have our awesome careers interactives. So students and teachers can go on and have a look at this animation that's in the middle of the screen there. You'll be able to have a look there and click through to see lots of different careers. About 20 different careers are featured in both trade and professional pathways. And there's also a video of a person who does those careers that you can then listen to around what their job is. Pretty much what this is similar way that Scott explained his role, but just in a quick 60-second clip. So thank you everyone for tuning in to our Batch Fire Coal and Chemistry webinar today. I know that we've covered off Central Queensland quite well. Again, if you have joined us today but you haven't yet let us know what school you're from, if you could kindly just type that in the chat box just so we can record that for our reference. And then if you do want some more information about other activities or other information that QMEA offer, we've got our info@qmea.org.au email address, our website qmea.org.au, and also our Facebook and Instagram page where we advertise other initiatives and other components. So thank you once again, Scott, for your time today, and hopefully everyone has a great rest today and a very, very safe holidays, and we'll see you all back in term 3.
Thanks, guys. Thanks, everyone. Bye.